Hi everyone, my name is Alevtina, and I would like to start by dragging your attention to this health data map that was created in Harvard University some years ago that shows how many different entities process and exchange our healthcare data in anonymized and non-anonymized fashion. So with this number of interactions, it's impossible to keep track of where our data are and who can access it and who is processing it right now. But actually, it would be really nice to know where our data are and be able to exchange it, because this can improve personal treatment outcome, it can improve medical research, create possibilities to conduct more clinical trials, and even bring the healthcare to the new level, like use the data that we all produce in order to enable AI-driven healthcare. However, with all this beauty of sharing data and accessing it, it's still important that the data of every single person in this big database, the privacy of every single person in this database is preserved. And because the harm that can happen, the harm is irreversible for this type of violation of privacy. And the government actually support these initiatives to allow the interoperability between different healthcare databases or different healthcare data sources, but ensuring that the patient can access the data and can decide with whom he wants to share what kind of data for what time, for how long. And here we are with a big challenge, how to achieve interoperability and privacy at the same time. Because of course we want to be able to access and exchange the data, but at the same time we want to be able to prove that the consent for certain actions is given. And this works for both sides. Sometimes people are really concerned about their privacy and they don't want to share data for research, but there are also other people that would like to share their data as they are, but because the data by default is being anonymized for research, then we lose a lot of utility of the data. So there are different approaches that try to address this challenge, like centralized approach or using the health information exchange. However, we're still asking ourselves how to ensure interoperability and privacy simultaneously. And this brings us to the question, why would we use blockchain for that? Not for the sake of using blockchain, and I'll try to convince you. So the idea of, so we started working on that idea some years ago, and the initiative actually came from the medical doctor that knowing some basic principles of the distributed ledger technology, noticed that there's a lot of similarities in the sense of this electronic health record management environment and the blockchain technology. So especially, for example, there is this distributed data sharing architecture where peers need to have the same data, need to process the same data, or where we need to keep some immutable history. So this is the same. We need to keep the whole history of access to the data, especially for the court cases in healthcare. So also the permission blockchain technology allows us to develop the efficient system that would allow this efficient and fast data sharing, which is sometimes really of life importance. So of course we're not going to put healthcare data on the blockchain because it's very sensitive and because of the volume of such data. But what we're going to put on the blockchain is a system metadata that includes the links to or references to the healthcare data that is stored securely and encrypted on the cloud server, and permissions specified by the patients for all these different categories of file or even the files. So we use the hybrid data management approach, and we really try to be patient-centric to allow the patient to decide which data to share with whom for how long. So we actually had our first prototype that long time ago with Fabric 0.6, where we modeled our blockchain network as having different hospitals, so even doctors coming together and then running the chain code that with just a very basic operations just to add the permissions or add metadata information while adding the data on the cloud. Then we would have the membership service that would verify the identity of every doctor, every hospital, and then the solution user, the patient or the caregiver, will be able to create the transactions in order to update the ledger or to query the ledger. But of course, so the problem of such system is that, of course, it's not possible to scale too much. And even if we think that we can maybe use this validating node as the very big hospitals, and then still with the evolution of Hyperledger Fabric, we also redesigned our system architecture, where currently we have, so we redeployed it on 1.0, then 1.2, and now we have it on 1.4. Which takes actually a lot of students and master projects to always keep up with the changes. But so currently we have, we model every hospital as a Hyperledger Fabric organization. And basically to start the network, you just need to have one admin hospital that would admin organization, order, and the cloud storage. So then the other hospitals, which are represented as Hyperledger Fabric organizations, can join the channel. And in every, so this allows us to have, in each hospital, to have its own role of administrator that can actually manage the identities of the doctors and patients. And then also we added the possibility not to just to share the data and upload the new permissions based on which the data from the cloud will then shared with the doctors, but also to have the possibility to comment the files that, that have been seen by the doctors, to comment the healthcare data. So here is just a few screenshots from the logs of. So I'm talking now about creating exactly the same the system as shown here. So where we have first admin hospital, and then we have just another hospital joining the network. So we have two organizations, and we basically start with just building. With having two peers of the first admin hospital joining the channel, and then we start our web server. Yeah, I should have said maybe here that we also, in each hospital, we assume that there is, we build the web server that has all the local healthcare data plus all the users registered. And we also have a web server where the registered patients and doctors can use in order to query and update the ledger. So here we start by just adding two peers to the channel. So we're having just one organization. Then we create the config file of the hospital 2 that wants to join this, this network, this new organization, and we install the chain code and then send the information about the order to the new joining peer from the new organization. Then now you see the screenshot from this new organization where we see how the peers from the new hospital are joining the chain code. And then we see that the last blog that was created with the latest configuration file is retrieved now on the second hospital that is joining the network. So then we have the peer from the new joining hospital joining the channel, and then we have the sending the information, and then the peer from the initial, from the anchor hospital, sends the configuration, learns the configuration of the new organization. Then we also need to upgrade the chain code, and we have the network of two organizations, order and a cloud server. So in the demo that I hope I still can show you, we have now we're moving from the backend to the web interface and to see what actually now we can do with this. So we have the network of two hospitals, two organizations set up, and with the patients and doctors enrolled. We want to demonstrate how patients from the first hospital can share the data that is currently reside in the hospital one with the doctor from another hospital that just joined our blockchain network. While this is happening, the data is also being encrypted with the public key of the doctor with whom the patient wants to share the data. The data is being sent to the cloud, and then this sharing transaction is reflected on the ledger based on the take into account for the time for how long the patient wants to share the data. And then we demonstrate how the doctor can see and can access the data and also comment and see other comments. So first of all, as I mentioned, there is this admin role. So here now we're on the first hospital, the initial hospital that was created, admin hospital, and we can see basically the list of the doctors. We can also add new doctors, and we can also see the list of the patients, and also through this admin console we can also add the new patients to enroll new patients in the hospital. Now we're going to use an example this patient in order to use now the patient interface in order to actually share the data. So now when the patient logs in, he can see his permissions, and he can also see permissions given to different doctors and also a list of caregivers. So now we're going to share the data category, which is history and physical exams, with the doctor from the hospital 2. And we're just choosing the first doctor, I think. Because here we already see the list of the doctors that are registered with the hospital 2 that just joined the network. And then we also have to specify what is the right, so to read, to access the data, and specify the time frame. So now we see that the data, we don't see how the data is being uploaded, but we see that the transaction is successful, and we now can see that the permission appears in the list of permissions and in the list of caregivers that can access this category of the data about this patient. During the specified time interval, we also can the patient also has a possibility to generate the report. And now I'm going to demonstrate how the doctor from the hospital that just joined the network and got the permission from the patient to access the healthcare data, how the doctor logs in, and then this is information that can be customized. And here in the list of the patients that share the data, we can see that there is now our category of the data of the specific patient with the permissions. So the doctor can download the data. So now it's being downloaded and decrypted from the cloud server. And so here we currently use, as I mentioned, the public key of the doctor, but we had we were really hesitating if we should come up with different approach and use, for example, patient-specific key so that we don't have to replicate if the patient wants to share the data with multiple doctors. But it all has its different pros and cons. So now we're demonstrating how the doctor can, after seeing the data, he can also comment on the data that he's seen, and these comments also will be accessible for the other doctors with whom this patient will be sharing the data in the future. So now we're just verifying that the doctor can see his own comment. So why we're not there yet? So you can't find yet, unfortunately, this kind of things in your hospital. And the reason is that while we we kind of able to provide the immutability of all these permissions or consents. And we can encrypt the data and say that we're really providing the secure and trustable data management. However, there are still a lot of non-related to blockchain issues that really not allow us to go there, like all this key management and all the credentials management, also identity management. Actually, now we're thinking to use deeds for also with this approach instead of using the standard identity management solution. Also, with this, what was one of the topics during the keynote is that interoperability is the key, and given that there's a lot of approaches and a lot of attempts to create this kind of systems, we risk to end up with having just multiple blockchain networks that are not able to interact with each other. And this what makes data actually, what makes the availability of the data limited. Also, by letting patient to decide what to do with his healthcare data, we're risking to end up in the situation where patient just doesn't share his data, or he doesn't share the very important data that maybe is really crucial for this particular diagnosis. So before allowing patient to really decide what he wants to do, like we have to come up with some mechanisms that would maybe define the minimum data that have to be accessible in case of emergency, for example, or for some basic diagnosis. Also, even that we're actually trying to make sure that these access control policies, these permissions, are exactly the same at every joining organization, at every node. We cannot actually guarantee that some nodes are not behind, and it's really a question if we have to just query one node or we have to query all the nodes each time we're taking a decision about whether the data have to be shared or not. Also, there are different limited capabilities of current blockchain technologies, even though now with moving to 1.x and 2.0, there is a big progress in the in scalability of Hyperledger Fabric. There's still a lot of there's still. It's hard to imagine that once we have all our data on, we have a platform that can support the healthcare data or even permissions of healthcare data of all the patients in the world. Also, even we try to move to having the chain code responsible for a lot of things, but at the same time, there still has to be someone that is writing this chain code, writing this smart contract. And by trying to remove the bias and making sure that everything is trustworthy and correct, but there still has to be a person behind that's the chicken and egg problem, I guess. And the last point, I guess, is that that is especially very relevant to the genomic data, even though we are not. Well, I don't think that anyone wants to put the whole sensitive healthcare data on the blockchain, but yet because even putting just the permissions, there's already a lot of risk to the violation of the privacy, because if I share my data with an oncologist, well, this speaks by itself. And also, when we talk about genomic data, by sharing this kind of data or giving permissions, we also risk the privacy of our children or of our relatives, which also, I guess, brings a lot of questions to the table. And on that very mixed summary, so I hope I convinced you that we try to use blockchain not for the sake of blockchain, but there is still a lot of stuff that has to be done, and that I hope that all together we can actually do. And on this, I conclude my 6 minutes longer presentation. Any questions? Sorry.
One of the things you had on the slide was the number of transactions the blockchain can handle. Can sense of what kind of transaction volume you're looking for this solution?
Well, I know that there are some algorithms and consensus algorithms that already can be implemented and can be plugged in Hyperledger Fabric that are like getting close to Visa, for example. But still, I think that so maybe this problem can be solved soon. But at the same time, it's hard to imagine how many, well, I'm not a medical doctor, but it's hard to imagine how heavy it would be if we really want to build something that is accessible and available for every person. Because even Visa is not available for every person. Yes?
You have two hospitals that were on that network?
Yeah. Exactly.
Does it have claim information? Like, can you pay like claim information, and can like a payer join that network see that like a claim has been paid? Or?
So this is something that, of course, can be. So for now, we just have doctors and patients. But of course, when we were just thinking about whether it makes sense to use blockchain, and I also know that there are different pilots that also include the insurance companies and doctors and this communication for the reimbursement, for example. So for that particular project, we did not have any other users yet. But of course, in that very optimistic slide, once in the hospital, we can get all different kind of users and actors that can, in the organization. So maybe it can also be the insurance company that is joining as well. And then by using different channels, having just access to subset of the information. And then this would allow us to actually to divide which kind of information have to be accessed by which entity.
Is this solution in production anywhere?
This is the pure research work. And, but we have interest from, so we're starting the pilot with one of the radiation oncology equipment company. And we tested it just on, so the screenshots that you've seen and the videos was just done on the two students' laptop sitting in the same room. But also we have, but on two different machines. So, and then, and we also have the installation with the Amazon cloud. So we have one, well, though we have just two Amazon machines, so we have like 3 hospitals, and also one AWS for the cloud server. So we also got interest from other hospitals. So we work with the Stony Brook University Hospital, and that's where we get all these healthcare insights. But we also got contacted by other hospitals that, well, we try to write some research proposals so that we can test it in different hospitals, because all this required, apart from this amazing making world a better place with research, it also requires some commitments and time. So, yes.
Care is a very long process, right? And while you have shown 2 hospitals sharing data, there might be some information which lies with the patient, which is more like a historical data. Have you kind of thought about or provisioned on how can more data sharing happen where it's not just hospital to hospital, but something that is lying with the patient, which is more like a historical data?
Exactly. So actually, for our very first prototype, we were thinking that we can have the option of patient just uploading the data himself and then sharing this data. So we just that's absolutely possible to add. So just we didn't implement it in a nice way, but this makes a lot of sense. And what we would like to do now is to have so based on all these permissions and the comments of the doctors, we actually, so now by having the ledger that stores the permissions of who can see what kind of data, now for every doctor we can generate the patient history that is allowed for this doctor. So that's what we would like to do next by processing the information on the ledger and trying to create this kind of full patient history.
Where is the data ownership here? Who owns the data?
The patient. Because, well, of course, the data always stays at the hospital where the data was created. But when we say that, well, that's something that I could have also covered a bit more. So when the patient uploads, when the patient wants to share the data and allow the when it allows the doctor to access the data, we set up the time for the time frame when this permission is valid. So we still have to put some trust somewhere. So we assume that the cloud server is only sharing the data when there is the permission on the ledger. So each time before sharing, there is a query to the ledger. And if there is a permission, the cloud is sharing the data. So the patient can also say, I don't want to share any more data by setting up the permission that expires now. And at that moment, by updating the permission, for example. And at that moment, if there is no permission anymore on the ledger, then we assume that the data will be deleted from the cloud. But this is still, there's still a lot of assumptions, but I see the point of your question. And the tricky part is that if you go out of the blockchain world, then how do you ensure that your data was deleted? So we can say that maybe there is another script or another chain code that runs and then periodically verifies the ledger and then deletes the data. But then again, nobody can prove that the data was deleted. But at the same time, what we also do is that we encrypt the data. So once the data is shared with the doctor, well, the doctor may never forget it. So that's fine. That's how we live. But the cloud server is not supposed to know the data at all because the data that goes there is already encrypted. So that's some small attempts to bring this ownership to the data to the patient. Yes?
So in this proof of concept working with Storybrooke, did you encounter any challenges with pulling that data from their EHR systems, like Epic or Cerner or Meditech? Because traditionally that has been the challenge with these EHR companies keeping the data as if it's their data, right? So just like Apple versus Android, right? One is more open, one is more restricted ecosystem. Similar thing that is happening in healthcare also with EHRs. Do you run into those challenges?
So, as I mentioned, we didn't run it in the hospital. So we ran it as every organization was run at the laptop. And we worked with the hospital just to get the insights and to understand how these healthcare processes work. But we are aware of these challenges, and we are working on using the FHIR standard. So for example, we can try to have well, all the data that is being imported. So it can be still, well, it can be in the best case scenario in the FHIR standard, as it has to be as it should be everywhere. But also there are different, what we try to use, for example, there are different software that also allow the conversion, for example, from FHIR to different standards, and then to use that. But, well, as I mentioned, we are aware of this. We are hoping to soon test it between the different hospitals, but we didn't do it yet. I think, thank you very much.